You call it light, I call it the electromagnetic spectrum.
Ooh.
I know, that was high end.
Totally.
All right, so before we even talk about what the electromagnetic spectrum is / light, they're interchangeable terms, a few vocabulary terms that we need to review.
Yep.
First
Refreshers.
of all, light does not require a medium, so it doesn't need matter to move through. What kind of wave does that make it?
Electromagnetic.
Got to be electromagnetic, yeah.
Yep.
I was about to give you options, but you got it. All right.
Sorry.
So it's all right.
Sometimes I know stuff.
Next,
Sometimes.
the particles in light move perpendicular to the direction of the wave. So if it's coming at you,
Goes
the wave,
up,
the
down,
particles
up,
also
down,
go like
up,
that.
down,
Now, does
and it's
that make
going
it
away.
longitudinal or transverse?
I don't know. You got this one?
No, transverse, right?
Right,
Because
sounds
longitudinal is the compression,
Sounds
rarefaction.
Rarefaction.
Yeah. So you
It's a
need to
tough word.
remember, light is also known as electromagnetic, and it is
Transverse.
So,
Sweet.
and leading right into that, light is really just a casual name for what we call electromagnetic radiation. And radiation doesn't necessarily mean like the
Something
bad
bad.
radiation that
Yep.
you
It
think
just
of.
means if it radiates, it just comes out. It,
yeah.
it flows out.
Like technically, you are able to watch this video because there is light
entering your eye,
radiating
radiating
your
from the screen.
Yeah.
Yep.
So
Hitting you in the eye.
not all radiation
Yep.
is bad. But anyway, in the study of light and its interaction with matter is called
Optics.
It's
That's
a
the
field of
science. Just
Yep.
a nice little thing there.
Cool. So one thing that's kind of a key thing with all this is the speed of light because it travels, and speed of light is
Fast.
ridiculously fast.
Yep.
Like way fast.
Redonkulously,
Yep.
I would say.
Even faster than mice on roller skates.
Yes.
It's
That's
actually
300 million meters per second.
or 3 times 10 to the 8th meters per second in scientific notation.
Yes.
Because it's a big number, so you write it small.
But the
So-
Earth is only 40,000 kilometers.
True, which is significantly smaller than the speed that light's traveling at. So what's neat about that is light will travel anywhere on the planet within pretty much a second.
Right.
That's
This is
awesome.
why you see lightning before you hear thunder. So talk about
Ooh.
Because sound is fast, right?
It sounds fast. It's very
Yeah.
fast, but it's not that fast. So that's why you see lightning before you hear thunder.
Ah.
Cool.
So anyway, so all light, whether it's visible or not, falls on what we call the electromagnetic spectrum. And that's what the picture is on the bottom of the screen. And right there on your notes where Mr. Harkins is pointing.
There you go.
So make sure I
Follow
can see over the
this.
sheet. All light travels at the same speed. So whether it's an X-ray or the color purple or a radio
Good
wave.
movie.
All I didn't mean to reference the movie, but all that radiation, it
I've never
travels
actually seen
at
it.
the same exact speed.
Okay.
So really the only thing changing with different types of light is the frequency, which by the way, what's the frequency of something?
The number of waves that pass a given spot in a certain period of time.
Right.
Per second.
Yeah,
Per,
and
per second.
The wavelength also varies because the frequency varies, which we can
Good.
mathematically prove, but maybe we'll do that.
So the
another
speed
time.
of all these things we're going to talk about is the same.
Mhm.
But the thing that varies is that frequency
Yeah,
or
the
that
frequency
How the
of
wave
wave.
looks.
Yeah.
How the
Okay.
wave looks.
Yep.
Cool. So it's just
So
change there.
keep looking at this picture as we go through the different types of light, okay? Because the thing is we're going in a progression. We're going
Right.
from larger waves with lower frequency
Yep.
to
Yep.
smaller waves that have higher frequency.
Frequencies and wavelength. Waves with a larger frequency, so that means more waves per second. So it's like this up, down, not like that.
Ooh, sick.
They're going to have a shorter wavelength, and that makes sense because you're going to have a lot more waves in that area. So they're going to be a short wavelength. They're going to be all packed together and get many, many more of them in that time
Because you
period.
got to pack small things.
Small things, you can get more things
Boring.
packed
Yep.
together. Waves that have a shorter frequency have a longer wavelength. So if you think about that,
Which also makes sense.
think about frequency as how frequently something appears. If it doesn't appear very frequently, very often, then it's got that longer wavelength because you may only have one or two waves in that same span, where if it had a larger frequency, shorter wavelength, you're going to see it a whole lot more in the same amount of time.
If you also just think about it, they just look like they're moving slower. They
Now
aren't
here's-
moving slower though.
No.
It's just there's less of them.
Yeah.
So here's the big thing here. Waves that have a higher frequency have more energy. So as the frequency goes up, it's a lot more energy, a lot more
Yep.
punch, a lot more power in that wave.
All right. So, and once again, reminder: make sure you're looking at this chart as we
Lots
go
of
through
time.
all
Over
different
and over
types of
again.
waves. We're going to start at radio waves and work all our way to
Gamma
those
rays.
high frequency, high energy waves.
Yep.
So the first type of wave we're going to talk about is radio waves.
Radio waves.
So radio waves, they have the longest wavelength of any other electromagnetic radiation.
Mm-hmm.
As such, they have the shortest frequency. So they're really long, so you don't get a lot of them, so they're short. They also then have the least amount of energy out of any of the waves. They're really good for communication, though, because since they're so long, they travel a very long distance without degrading, and they can travel through a lot of materials as a result of that.
They're all around us all the time, right?
Yep.
Like
You're
we're
getting
getting
hit with it right
blasted with them
now.
right now and going through us and through everything.
Yep.
Yeah.
Close to that is microwaves. And we're not just talking about your microwave oven. We're talking about a certain frequency, a certain wavelength there. It's a specific type of radio wave. You can use them for communication. You can use them to heat things up. You can use them for your earbuds,
Are they
anything
heat
that's
waves
wireless.
themselves, though?
They are not heat waves. So they can cause a heat-like effect by exciting molecules, but they themselves are not a heat wave. A microwave is really close to a radio wave.
Yeah. Yeah, it's a type of radio wave, right?
It
This
is
is
a
actually
type
what
of radio
PlayStation uses to connect the wireless controllers to the
Yep.
PlayStation. Also.
Yeah, it's related to Bluetooth and some of those things.
Yeah. So infrared, also known as IR for short, infrared waves are not visible. We do have
To us.
cameras. Yeah, we have cameras that pick them up very easily. But even
Yep.
really, I don't want to say cheap cameras, but just
Yes.
normal cameras can pick up certain infrared radiation. So one kind of interesting use for infrared radiation is your remote control for your TV sends infrared beams to your TV to sense to, or to tell it to change channel.
Yeah.
Now, if you took your iPhone, you could probably hit the channel up button on your remote. You can see it light up. Although to the naked eye, we can't
won't
actually
see it, but if you
infrared.
shot it at your phone, you could see the little pulsing of the light bulb
Your
in the
phone
end
will
of the
pick it
thing
up.
there, the little LED.
But anyway, infrared waves are given off as things heat up.
Yep.
So have you ever seen a movie where they use like heat-seeking goggles? What they're doing is they're looking at infrared radiation. We also use them as like we do infrared bulbs to put over food at like fast food restaurants.
Yeah, to
It's
heat up your
even more.
burgers and
So
stuff like that.
you can have a 30-minute-old burger.
Yeah.
The next type is visible light, and we're actually going to spend a lot more time on visible light in a future video. So just
The next video.
Oh yeah, the next video.
Yeah.
So just to kind of go over it real briefly, visible light is actually the smallest, teeniest, tiniest part of the electromagnetic spectrum, but it's also the only part that we can actually see. So when you see stuff, you're seeing literally light bouncing off of everything around you and going into your little eye holes where you can actually see stuff.
Yeah.
Yep.
And even the picture that's on your notes shows that visible light is a very small section of your electromagnetic spectrum, and I would even say
It's even
smaller than
Yep.
the picture makes it
almost
look. They needed
nothing.
to fit it on paper, so they made
Yeah.
it bigger than it really
Yeah.
is.
And you had to be able to see it. So
All right. I'll take this one. UV, ultraviolet light. Wait a minute, ultra. Ultra means like beyond, right?
Yep.
So like ultra,
Or
like
more.
ultra or more than. So it's more than violet. I get it. So it's ultraviolet light is still beyond the visible light, beyond our violet part of the light that we can see.
with a more frequency.
It's got a light. It's just that much shorter than what our little eyes can pick up in that. So that's why they call it ultraviolet, because violet's kind of the end of what we can see. We need ultraviolet light. We hate ultraviolet light. A little bit ultraviolet light's good for like causing our skin to produce vitamin D, which keeps us healthy. We get it from the sun. The ultraviolet radiation gets us.
In fact, if you get no sun,
If
don't
you
get
get no
vitamin D,
sun, you'll
you
get
bad.
very sick. You can't absorb calcium well. It does all kinds of bad stuff for you. If you get too much, you can get skin cancer, sunburn, all kinds of bad stuff like that too. So you want to get the right amount. So again, it's not all bad or good. Ultraviolet light has its benefits. You can
In
also use them to
moderation.
sterilize
moderation,
things.
yeah.
In our goggle cabinets, if you guys look in there, remind us to pop open the goggle cabinets, and we can show you guys the ultraviolet light bulb that's in there. That helps to keep your goggles that you wear in labs from getting all grimy and grody from
Kills the
bacteria and
bacteria.
stuff.
Yep, kills off the bacteria.
Kind of cool.
All right, next group, X-rays, which you might be familiar with. Hopefully not too familiar with, because they are used to scan your body for broken bones. But the reason they're able to do that is because they're so high frequency, they can penetrate solid objects. And we often use these for security also. But however, if you're exposed to these, it can also damage human tissues. That's why if you get an X-ray, they put like a big lead jacket on you to block.
Anywhere they don't want that
Yep.
X-ray to go, because it
Like-
can damage you.
Right.
The last one that we're going to talk about is something called gamma rays, and gamma rays they're pretty cool. They're really, really bad, but they're really cool. So we say that gamma rays are extremely rare, at least on our planet. The only place you really find gamma rays on our planet is when a nuclear explosion happens. Otherwise,
do it.
you're going to find them out in space from stars. So they're common in space, not so much here. But what's neat about them is they have a huge amount of energy. So they have a really super high frequency, lots of energy coming through them. And so they're way over at the far end of the electromagnetic spectrum. Now, the reason why it's kind of popular is if you know of a character from the Avengers called the Hulk.
Yep.
His alter ego, Bruce Banner, was testing this stuff, and he decided, hey, I'm going to blast myself with it, because why wouldn't you just test yourself with dangerous stuff?
Of course,
Like,
it's
we all
only
do it.
radiation. Like,
Totally.
get some.
So he gets blasted with it, and it turns him into a Green Rage Beast. Unfortunately, most likely, it just would have probably given him lots of cancer. He would have died in about a week, probably.
Wait, so
at the
movies
best.
aren't real?
No.
Oh.
This one is, though.
Yeah.
This one's real.
Well, on that note of disappointment, that I can't turn myself into the Hulk. I
What
think
about the
we'll save
internet?
that.
The internet's
I
real,
was just
right?
about to cram myself in a microwave and see if it changed me into some kind of superpowered being. Forget
You'd
it.
probably
Alright.
turn red.
I'm not doing it. I'm out.
Have a good day.
Bye.